Hello and welcome to the um, first test, practice test. Woo! So let's go over what we're going to be doing today. We're just going to walk through this, and I hope you enjoy and learn a lot. So first, we're going to label the different parts of the equation. So we have y equals mx plus b. That is our equation for slope, or for the equation of a line, right? So, and the m, the number next to the x, is our slope. Slope. Hello? How do I move it? Anyways, all right. And then the b hanging off the end is our y-intercept. Intercept. And that is where our graph hits the y-axis, which you can see on this problem over here. So for this next one, it says write down the slope and the y-intercept of the following equation. So the slope here is next to the x, which is 1/2. The y-intercept is a number hanging off the end, which is 2. Here, our slope is not a negative sign. What's the number next to the x? If there's no number, we can write 1 because there is 1x, but it is negative, so it's a -1. And then the y-intercept is the number hanging out the end, which is -3. Now we're going to draw a line based off of this equation. So we have y equals -3x plus 2. So just what we did over here, our m here is -3. Our b is a +2. We use this first, b first, and the slope second. So we're going to start with our b, which is our y-intercept. So we're going to go to our y. We're going to make a dot on the y at 2. Now, to use our slope, we want it as a fraction. So I'm going to divide by 1. So we can turn any whole number into a fraction by dividing by 1. The top number tells us where we're going to go. So we're going to go up and down with the top number, and then left and right with the bottom. So since it's negative on the top, we're going to go down towards the negative numbers here. And then since I made the bottom number positive, we're going to go to the right towards the positive numbers, right? So there's only one negative sign, so only one of the numbers goes negative. So we go down 3 over 1, so down 1, 2, 3 over 1, make a dot. Down 1, 2, 3, make a dot. If you want to do multiple, you can make a line. So you can go backwards if you count up 1, 2, 3. So going the opposite. So up 1, 2, 3 over and that's where we would have a line, right? And so you can see our line is going to go perfectly through these two. So we get a nice line. Very nice. All right, moving on. So all right, so what do we have? We can write our type of correlation we have. So here, our first correlation is so always feel free to draw a line, right? So you can see this amazing line I drew. Yikes, this is an awful line, but we'll pretend it's good. So this line that goes right through the middle, all the numbers are really close. So this will be a strong, because it's all close to the line, but negative because we're going down and to the left. Down. This one, right, we can draw a line. And so we would have so see how it's not very close to this line? So we have a weak positive correlation. So it's weak because, see, the dots aren't close to the line, whereas this one is really close to the line. And then this last one is pretty easy, right? There's no line that we could draw that would help us with this line, right? Like here, right, like if I drew a line like this, would that make any sense? No, right? Because the dots don't follow this line, right? They follow an upward trend. So our last option is going to be no correlation. All right. Now, here we want to circle the two variables we use to test the research question, right? So we want two variables, right? We want to see how much a fish will grow. So what are ways that things grow? They can either grow in weight. Here, they can either grow in weight or with like height and stuff, right? Weight and like height. And then the other thing that we're testing is during the school year, which is a measure of time. Right? And so we want to find the two variables that represent either like a weight or like a height, right? Something that grows, and then a time, right? So color of fish, that's categorical, so we don't want that. Breed of fish, like goldfish or some other type of fish, we don't want that either. Weight, that matches up, so that's good. So we've checked that variable off. Now we're looking for something with time. So months after purchase, that's a time. That's going to be our other answer. Food eaten isn't going to be help us how much it's going to grow, right? It might be some indicator, but not the best. All right, moving on. So we're going to draw a line of best fit and then predict the test score of a student. So I'm going to take our line tool. On a test, you can use a ruler. Right? And so you can see my line goes right through the middle of our data. We got a line arrow to both sides. And then what you can do is you can use your ruler. And so you see how we have 5 hours? Keyword hours. Always look at the axes for the units, right? So in this case, we have hours. So even if you don't know what this question is asking, right, like you don't know what the context is, right, what it's asking, you can use the units to help you find it. So we want 5 hours, so we're going to go on the hours. We're going to go to 5, right? We're going to go up to our line. Because if we get a new dot, where would we expect it to be? We would expect it to be on this line. So we expect like a new dot to be like right here. So we can go over and look what our y value is, and that is going to be 85%. And so you want to show your work by using these lines straight up from 5 and then straight over, so that you show that you know what you're talking about. Now our next one, Miss Rivera Saunier found that if she drank many cups of coffee, she would be able to grade more tests. The line of best fit she found was given by y is approximately 5x plus 15. So this is our equation of a line, right, that we can use for this equation, right? So now we want to write down what x and y mean, right? So x is going to be a thing, right, is going to be our IV, right? It's a thing that we can control, right? And so what can she control? She can control how many cups of coffee she drinks. So the x is cups of coffee, right? So sometimes that's time, sometimes that's miles ran or something like that, right? And then the cups of coffee is going to impact the y, which is the number of tests. Number of tests graded. So if she drinks more coffee, right, she might be able to grade more tests. Now we're going to use this line of best fit. So that was 2 points right there. Boom, boom. See, 2 points. We use this line of best fit to predict how many tests. How many tests is what variable? Y. She would need to grade if she drank 2 cups of coffee. Cups of coffee is an x, right? And so see how this 2 is going to be our x. So what we can do to show our work, we can say y is approximately 5. Now instead of x, what's x going to be? X is going to be 2. And then plus 15. And then you can type this into your calculator, or you can just do the operation. So 5 times 2 is 10, plus 15 is equal to 25. And so she can grade 25. And don't forget the units, tests. All right. Last but not least, on this page, we're going to be plotting some points. So we're going 1 through 10, and we're going to plot some points. So 1's at 25. 2's at 23, so that's somewhere a little bit above the middle. 22 is a little bit below the middle. 20 is here. 19 is here. 17 is here. 16, 15, 14, 13. Okay. So we have our points, right? And so we want to draw a line of best fit. So we're going to use our ruler, draw a line of best fit, right through the middle. Boom. Add the arrows to the other side. All right, so we have our line of best fit. See how it goes to the middle of our data, right? It's not up here. It's not down here. It's not doesn't do one of these, right? It goes to the middle of all of our data, right? That's our line of best fit. Now it says, what does the y-intercept mean in context? So the y-intercept happens right here, right? And so if we go down, right, what's the x value here? Well, the x value is 0. And the x, if we label this, so you always label your tables, the x is the hours of exercise. So if the hours of exercise is 0, what does this mean? It's the body fat percentage when you exercise 0 hours per week. No. All right. Nice. All right. Last section, section C. So it says, which of the following questions can be used to collect data for a scatter plot? So remember, a scatter plot has an x, has a y, right? So we need 2 variables. So 2 variables. And it needs to be quantitative. Quantitative. Which means you can measure. Something you can measure. Right? So what's my grade in math class? Well, that's grade's the only variable, so that's only 1. So it's only 1 variable. How does my height? How's the height? That's good. That's a variable. Impact student test scores. That's good. But does height have any impact on test scores? Would that be a good question? No, right? So not. So the 2 variables are not related, without even like we wouldn't expect them to be related. How does hair color affect test score? So similar issue as the last one, but here we have a categorical error, so that's not good. So this is category. Category. And how much time the student spends studying, right? That's our variable, and then test score. Those are 2 measurable things, and one would have impact on another. So that's where we're at. Now, a restaurant wants to see if they should add pancakes to their menu. Write down how they should collect the data to have an unbiased sample of the customers, right? So they want to, unbiased means they don't want to be partial or favor any particular outcome, right? And so you don't want just the breakfast crowd, you want to see if everyone, right? And so you want a random you want to survey a random sample of customers from throughout the day /week. So you don't want just Monday people, you want a little bit of everyone, right? But the key word here is you want random. Random is what's important, and then you want to make sure you're covering all your bases. So you're not just focusing in on one group. All right, our last review question. Mr. Herman was working on the problem below and made a mistake. Write a sentence explaining his error and then find the correct solution. So we look here, given the equation y equals 2x plus 3, what would be a new line that is twice as steep? So the key word here is steep. So if you look at your notes, steep represents slope. Slope. So we want to change the slope, and then twice means we're multiplying by 2. So let's look at Mr. Herman's work here. So we have y equals 2x plus 3, and then he's going to, so that's where we started with, and then you're going to multiply by 2. So he's going to multiply the 3 by 2. Now, here we have an issue, because what's the number hanging off the end? Is that the slope? No, that's the y-intercept. So he multiplied the y-intercept instead of the slope. So what would be the correct work? Well, so we can write it out. So y equals 2x plus 3. Now we want to multiply by 2 our slope, which is this. And so when we write it out, we have y equals 4x plus 3. So notice how the slope changes, but the y-intercept does not. And that is our review for this test. Good luck studying and have fun.